And we're back, and it's COMP392, and it's the winter 2016 semester. It's week 4, lesson 4, part 4, right? And what I want to start talking about right now with you and kind of outlining in more clarity is assignment number 2, which I'll be honest with you, I've done this kind of assignment before, and it's been the consternation of many a student, right? So please don't take this one lightly. This one can be a little bit more tricky than the other one. Not that I'm trying to make it tricky, but it's just the details that are can be a challenge. And how do you propose to do this stuff? There's different approaches to this problem. Let's take a look at the details. So assignment number 2 is called the solar system, right? Solar system. We did some rotations with the cube man. Now we're going to make a 3JS solar system with TypeScript, right? So what does that mean? So we're going to make a application that displays a fictitious solar system. This is not Earth's solar system, our solar system. If I got you to make our solar system, it's very challenging to do because there's so much detail and there's so many planetoids and so on. That's too hard to do. So instead of making a realistic model, I'm going to make you make your own. All right, so you can make your own solar system. Please don't use some weird Borg cubes for your planets. That's all I ask. Okay, don't make some weird things that rotate around the orbits. But let's talk about this thing. So I want at least, so one sun, here's the rules. One sun, 5 planets. One of those 5 planets has to have a moon that orbits around it, right? The moon and the planet will orbit around the sun as a group. Okay, that's what's going to happen. Okay, so pretty simple, right? Here's what I'm not asking you to do. I'm not asking you to put any textures to any planet. So that's all bonus. We'll talk about the bonus. I'm not asking you to make elliptical orbits. They can just be circular orbits. So it's a model. It's not 100% realistic. It's okay. All right. I don't need you to make elliptical orbits around the planets and so on. Okay. I want you to have controls, and the controls will do 2 things. It won't change the rotation or anything like that and make it crazy. The only thing I want you to do is zoom in to see or zoom out to see the entire solar system, the 5 planets and the sun, from some angle, so I can see the entire solar system, right? And zoom into the planet with the moon, so you can see the moon orbiting around the planet, right? So that's what the zoom controls will allow you to do. So when I say zoom, what am I really doing? I'm moving the camera, right? So I'm moving the camera, or as an alternate, and this is up to you, use the second camera. Now, I haven't talked about second cameras, but I have to turn one camera off, turn the other camera on, make the second camera the active camera, and switch between the 2 cameras. That's another option for you. I'm not going to make you use one camera if you don't have to, but you could certainly zoom. It's going to be a neat effect if you use one camera that kind of moves from one kind of location down to the other and then back. That's kind of a neat effect because you'll see that in real time, right? But you don't have to. So that's really it. That's what I want. Okay, that's the basis. Now this, when I say that's all I want, now you get a few weeks to do this because right now we're sitting at week 5 this week, right, for Friday. I'm giving you until week 6, effectively, or this is week 4, but this is February 5th. Week 6, we have a break in between there because not next week, which is week 5, but the following week is our official mid-semester break, right? So I won't see you to get this done until February 26th, which is near the end of the month, which means you effectively have 3 weeks if you use some of your off time during the break, right? That's when it's due. So lots of time to get this done. And unfortunately for this, I have to be honest, right? When I give you more time to do a project like this, usually people mess up even more when they have more time, right? It's almost like if I have a tighter timeline for you guys, you get it done. If I have a bigger timeline, you know, something breaks and you don't do it because there's other things going on at the same time. Please start this early. This is something that needs attention, all right? Because even though it's worth 10% of your final mark, it's not a lot of marks, right? It takes some details and some programming to get all this right, right? So let's talk about the details. It's 65 points, if you will, for those 10%. So a little bit more challenging to do than the first one. Again, the first one would be out of 10, I would probably say it's probably about a 4, right? You know, I don't even think a 4 would do it any justice. Take a look at the marking scheme. If I've got 10% and I've got 65 points, that's like a 6.5, 7 out of 10. That's typically what it's like, I've noticed, in terms of difficulty. Because it's more requirements. The more requirements, the more challenging it is, right, in terms of challenge out of 10. 6.5, maybe 7 out of 10 for most of you to get this done right so that you get all your maximum marks. Why? Because that means that there's some challenges, there's some things you need to take care of that I won't be telling you how to do from now, but we'll be working at it over the next couple of weeks to kind of show you how it's all done. But, and we're going to talk about lighting in general and how to do things like rotations and things like pivot points and all that stuff over the next couple of weeks. We'll be talking about all those kind of things and how to group things together, objects together, which you probably learned about if you did your CubeMan assignment already. You kind of learned around grouping a little bit. And there's different ways to do that. So that's a lot of stuff you can learn here to do this. So let's talk about the details. So a helper axis, I still want a helper axis in the middle of your scene. It's not going to make the scene look beautiful. It's just there for you to understand, so when I look at the scene, I can see what the axis looks like. Because we're not going to have any kind of plane in this scene, right? So it's just going to be a bunch of planets orbiting around each other, right? And that's going to be somehow difficult to understand what's happening in the scene. So that's why I want you to put the helper axis there. The control panel that has those at least 2 buttons or some other controls, I'm not going to tell you how to do this because I want to give you flexibility, not because I want to make it more ambiguous. So that way, if you want to have more than one control that allows you to zoom and rotate and do other things with your control, I'll let you do that. But the 2 things I want the controls to do is zoom in or zoom out, first of all, to see the entire solar system, and zoom into that special planet that has 1 moon. Okay, as long as you can do that, that satisfies that requirement, right? And that really is controlling the camera, right? That's what it's doing, or a second camera, like I said before, right? So C is a sphere that represents the sun of the solar system, right? It should be colored either white, yellow, or red. Different illuminations in terms of how real life they are, right? Kind of, right? It's not super realistic. By the way, I don't expect you to animate the sun like it looks like it's burning with any kind of particle effects or anything like that. If you really want to challenge yourself, you can certainly do that. But that's a lot of work to do, coding by hand, right? So be careful about particle effects. The sun, though, this sphere, I want it to look like, okay, it doesn't have to be itself, but I want it to look like it's emitting light, okay? I want it to appear that it's emitting light, that the light's coming from there, right? There's different ways of doing that, okay? There's different ways of making the light source, as an example, a point lamp that's really, really bright, or some way, but it has to cast shadows. So think about the kind of light that would work to cast shadows and how that would work, right? Okay, so that's one. A sphere that represents the sun. The next one is 4 spheres. So 4 spheres that represent the 4 planets without moons, right? Because there's going to be some planets without moons, just regular planets. But to make it interesting, what I've asked you to do is make them various sizes. So don't make them the same size, and color them differently. Make one red, another one purple, another one green, whatever, right? Make them different colors to make them look different, right? And different sizes, big one, small one, so again, to make it interesting, right? And have them orbit around the sun, which is a rotation, rotate around the center point at different speeds. So choose one. It's random for you guys, whatever you want. This is up to you. This is your creativity, right? You can make one rotate really slowly and the other one rotate really fast, or much faster, and so on, to emulate what it is to, for some to be moving faster than others. Typically, the ones farther out are slower than the ones closer in, right? Why? Because of the orbit size, the circle, the rotation size. But you can also add speed to the orbit because, it depends on how fast it's traveling around the sun, right? All right, so that's that one. Notice that I didn't ask for any textures, so you don't have to put textures, just materials. So all I'm asking for is a Lambert material that takes shadows here. That's what I'm really asking for. That has some kind of color attached to it. No texture so far still, right? That means you have some bonus opportunity to add textures of your own if you so feel like, right? It's up to you. One sphere that represents the planet with the moon, right? This doesn't have to be the Earth, okay? This is just like something like that, right? So the planet will also have another sphere, a moon, that orbits or rotates around its own center. And the planet and its accompanying moon will orbit the sphere representing the sun together as a group, okay? So it's going to rotate, and this is going to still rotate as it rotates around. So there's extra rotation, right? So that means lots of control and some programming for you guys, right? Okay, the background should be rendered as near black or dark gray. So it doesn't have to be pure black, all right? It doesn't have to be, because sometimes that messes up with your lighting, right? If you make it pure black, it's hard to see, some of the planets and everything else that are around there. And I'll show you an example of that. Sometimes it's easier to make it a little bit dark gray or create something called a skybox, right? Which we haven't talked about, right? But you can certainly use some kind of skybox or sphere that represents the area outside of your solar system, right? I'm not going to make you do it, but I'm going to say that that's possible. You can think about making a background that makes it look nice. I'm not going to enforce it. But these are the things that you can do. A perspective camera that allows the user to view all the components in the scene and change orientation when the appropriate control is adjusted. In orientation, I mean zoom in or zoom out when the control when the control calls for it. I also want you to include an ambient light. Even though in real life we don't have an ambient light, sometimes we need something like that to light up the scene a little bit, so make sure we can see all the planets, right? What I don't want to see is a white background. So the ambient light shouldn't be too bright. It should be just barely enough so that we can see, the objects in the scene. All right. All right. The rest is the same. Internal documentation and site structure, the same site structure that I looked at before with TypeScript and everything else, and GitHub and your cloud deployment. So that's all the same. Nothing's different. Just that piece. Make the solar system. Now, I've also included a bit of examples of where you can get some bonus marks. Some of them are easy, some of them are challenging. So if you're someone like a Steven who wants to challenge himself, this is the place where you can really do it. Here's an example. A, add textures to each planet to make them more realistic. So get some, some kind of rocky textures, or, maybe some watery textures to make a water planet, or clouds, or whatever you want to do. This can take a lot of effort for you. Please don't go too crazy, right? So if you do it to all the planets, 5 bonus marks. Add textures to the moon. Only 1, right? You get 1 bonus mark. Have the planets orbit around the sun with an elliptical motion. So more math involved in terms of making it an elliptical orbit, which can make it more complex, way more complex. Also, if you make the planet have an elliptical orbit, all of them have to have it. If one has it, pretty much all of them have it, or else they'll collide, right? You'll have some weird collision. By the way, there's no physics here, right? So I'm not asking for true motion or physics or anything to do with mass. Don't try and go there, guys. I've had people do this exercise in the past, and they've tried to do a mass, like incorporate mass in the sun and everything else, crazy like science and stuff like this, and they wouldn't finish. They didn't finish. It was great. It was a nice example, right? But they were late, right? So don't be late. I just want a model of a solar system, a fictitious solar system. It doesn't have to be accurate. Enable the controls to zoom in and out, right, to other planets of the solar system. So don't just enable them. That's like for 2 simple marks. So if you make it so that the camera can go to planet 1, 2, 3, 4, 5, all those different places, great. That's going to look a lot more awesome, and I'll give you extra bonus points for that. Give one of the planets a ring, right? So make it so like a Saturn-like ring structure, right? You have to decide how to do that. And there's different ways of doing it. You can make it so that there's little bits that kind of go around the planet, or you can make it so it's one continuous ring with a texture around it. It's up to you. Add additional moons that orbit some of the other planets, but ensure that at least one doesn't have a moon. So don't make every planet have a moon. You can make multiple moons, different things. I'll give you a couple bonus marks for that. Add an asteroid field. Now this is where it gets nuts, right? Add an asteroid field that orbits around the sun. This could include several asteroid shapes that repeat, as an example, in that little asteroid field that kind of orbits around the sun. And then, of course, the final one would be add a second sun that effectively creates a binary star system, right? Most of the planets will orbit around one sun or the other. One planet may have a unique orbit that allows it to orbit both suns in an infinity-shaped loop, right? It would kind of be a weird loop. Be careful with this kind of stuff, guys. It's insane, right? I'm just saying, right? If you want to challenge yourself, here it is. And this is for all bonus. By the way, all of these bonus marks are cumulative. So I will give you as many marks as you get. So if this is worth 65 and you get all these extra bonus marks, if you get 75, you get 85, whatever it'll be, I'll give you that many bonus marks, right? I have no problem with that. So it's up to you what you're going to do in the next few weeks, but it has to be your own. Remember that I want your, I know, Ryan's laughing. Some of you may be like, holy crap, right? It looks big. It doesn't have to be big. If you want to keep it simple, and let's go back down to Earth a second, out of the solar system we're making right now, right? Because we're dreaming, right? Let's go back down to Earth. Back down to Earth, I'm looking for 5 planets, 1 star, right, equivalent, and 4 of them, no moons. 1 has a moon with some simple lighting, and I zoom in and out of the planet with the moon, or to see the whole solar system. That's it, with different colors. Really, I would start with that. Start getting that done. Do the low-hanging fruit. Do that easy exercise first. I'm gonna put like these air quotes here. Easy exercise first with round orbits instead of elliptical orbits. Get that done. And if you're there, then add to it. Don't try and go crazy and add elliptical orbits from the beginning. It'll mess you up. I've done this before. I've gone there. You're not the only class that I've had this assignment given to, and it can be deadly, right? So, but it's neat. It can be really It can be really creative, and I've had some really cool creative submissions in the past using other kinds of programming languages and graphic user interfaces. Okay, so just letting you know, there's been some really cool things. So just you can go from really cool, and then you can just fall down on your head on this one. So please don't do that. Okay. Questions around this assignment 2, right? Yes.
Can you show us an example?
I don't have it, but I will. I have examples of other student works that have done it. Yes.
Do we have to use TypeScript?
Yes. It's part of the requirement, right? Steven, right? I know. You want to use something like something else, like C# or something. No, don't do it. You can't use C#. You can't use C++. You can't use Unity for this one. You need to use 3JS with TypeScript, right? 3JS with TypeScript and JavaScript, right? So please don't use Java. Don't use GDX or anything like that. You don't want that. I don't want any of those other systems, or C++, or any other kind of operating system or language or anything like that. It's just 3JS. That's what it says here in the example, right? So it's going to make it challenging for you because you're going to have to learn how to do this all with, with 3JS. So how would you approach it? So let me ask some questions. I want to put out there. So how would you start approaching this problem? This is a problem that I'm giving you. So here's the problem. Your employer has asked you to create a model of the universe, starting with the solar system, right? Or you're making a video game with your own solar system, right? This could be the other way of thinking about it, right? And the solar system is going to be realistic to some degree, right? Can't be fully realistic because it's just the more realistic it gets, the more time. That's really what it comes down to, right? So you don't have that time for the quality. And then whenever you think about a project, right? What are the 3 constraints that we have for all projects that we do ever in software application design or any projects in general? Anybody? Can anyone remember those 3 constraints? Anybody? You guys don't know project management? Come on, 3 constraints that affect all projects. The triple constraint triangle. Price, time, and quality or scope, right? Right. So depending on how you go. So the scope on this one isn't that big. It's small, right? Relatively to what I'm asking you to do over the next 3 weeks or so, right? Please don't do the scope creep thing, because then you'll be a creep, right? We don't want you to be a creep, a scope creep, right? I want you to keep the scope creep low, right? So plan out your first phase, get the basic requirements done, and then if you have time, add details, add features. That's what I would approach it, all right? Number 1, okay? The other so the 2 are cost. Is there a cost in this particular example? Probably, for you, there's not as much of a cost, but think about your time in hours, okay? So time and cost are kind of related, right? Because, you can take more time, but then in the end, it's going to cost you more money. And cost is also how many resources I have. You only have one person doing this. This is a single project. You're not to do this with anybody else. This is supposed to be yours and yours alone, right? That you're doing. So for this project. So this is your project, right? So if this is your project and you're doing this thing, as an example, and again, we're going to be talking about lighting in this one. By the time we're hitting it, we're going to be talking about things like different shapes and all that kind of stuff. And I'll talk to you about the schedule, which is, again, I'm trying to follow the schedule that's in the book fairly closely. We're about a week behind in terms of everything that we're supposed to be doing. But overall, we're going to hit all the objectives here with this one, right? So again, time-wise, it's only you, right? So that means the more time you put into this thing, and if we look at the total, total time here, if I look at total marks, here's how I usually look at it. I take the total marks, and I figure like this. It might take me, right, for me, a few hours to get this done. Me, to do it right. Maybe 3 hours, or I would say to just get the basic one done. That's reasonable. How long would it take you to do, right? If it takes me 3 hours, okay, it's at least double the time, maybe. I'm I'm being nice, right? Let's say 6 hours, right? Right? At least I'm saying. And I'm not saying that I'm awesome, but I just know this a little bit better, right? So maybe it would take you 3 hours, maybe it take me 4 hours. I don't know, right? But I'm saying something like that. So if it takes me 3 or 4 hours, and I'm telling you, I know that it'll take me this much time because of the programming involved and the testing involved, right, to make this go, right? 3 or 4 hours to make this good. It's going to probably take you at least double the time, right? So at least I would put out there, at least 6 to 10 hours, let's say, at the minimum, to get the first part done, right? A 10-hour project, guys, is not easy to do, right? Because you have other things going on. So please don't wait. So here's what we're going to do to help out. Next week, I want to see it. I want to see what you guys got started next week, right? And I want to, I haven't broken this project out. It's worth 10%, right? But next week, I want to see what you've got, right? If you haven't started by next week, right, or have a start, like have some spheres and everything going on, I'll tell you right now, you're in jeopardy because it's going to take time to test everything, right, to make sure. And there's also the documentation that needs to be done. Notice how there's an internal documentation. You need to do this. I haven't asked you for an external document yet, but it's coming, right? Because there's a lot of other requirements here, and I don't want to burden you with an external document as well, like some kind of document you have to produce, right? So internal documentation only is pretty good. Like if you ask anybody, I always give external documentation for all my assignments, but not for this one, and not for the last one, because there's so much that you're learning all at the same time, right? I still think you should plan it out, and I still think you should model it out. And if I was going to start this assignment from scratch, and I've never done it before, I'd probably model it out with something like a blender, right? I'd model it out first. Get your spheres done. Balance them out. See what you want to make your solar system look like with Blender. And once you get your solar system looking pretty good with Blender, and you've got the positions, the lighting, and everything else going, try and mimic that with 3JS. That's probably the easiest thing to do, guys and girls. If you try and do this out of the top of your head, right, you may not get the results you want, and it might frustrate the crap out of you all, right? So please don't do that. Please start with some kind of modeling tool, Blender, Maya, 3D Studio Max, whatever you're comfortable doing, right? To kind of visualize, what the solar system is going to look like, right? Any questions around this? Blender, how do I visualize? We'll start doing it. I'll start showing you. We'll start making some spheres even today, right? And talk about lighting. We're going to be talking about lighting anyway. Might as well use spheres to give you the example, right? All right. Who's going to challenge themselves? Anyone interested in challenging themselves with this one? I see one hand, right? I see a couple people that want to challenge themselves. This is good, right? And then another one. So again, for the people who want to challenge themselves, I know you're going to say, yeah, I see how I can do this. I got it. Guys, I want the minimum viable product first. Please give me what I've asked for. 5 planets, the thing I'm looking for. If you can do it as early as next week, that'd be great. And the reason for that is the earlier you do the initial pieces, that's 100%, right? That's going to net you 100% right there. Then spend the rest of the time playing. I have no problem with that. Okay, rest of the time playing. So why am I giving you all these bonus opportunities? Because you know what? I know that I'm challenging you. Every time you come in and do a little quiz with me, it's not perfect, right? You're not getting 5 out of 5, right? Well, for the most part. I don't mind giving you all 100%. I have no problem with that. But that means you got to put that extra time and bonus to get your bonus marks, right? It's great learnings for you too because you're going to push yourself, right? But first, let's get that minimum viable product, that MVP. Get that part done, which is what I've asked for, the requirements. Hit the requirements first, and then expand it to the next feature set, all right? Please don't try and do elliptical orbits, I told you. That kind of stuff first. All those other things that you can do to expand, to make this solar system into a universe. I had one student at one time, not only he did that, but he made several solar systems, all right? Yeah, to create almost like a cluster, right? And to me, he went nuts with it, right? He had a lot of sleepless nights, and this took him like many, many weeks to do. He was late. He did, submit late. And with all his work, I could only ever give him 100% because he was late. Like he was late a week. And normally I don't want to allow that. But I mean, he asked me for specific, leeway, and he showed me what he was doing. It was impressive, but he went nuts, right? But that was him. Doesn't have to be you. This is just one assignment out of a couple, right? A few more, right, that we're going to get. So don't go nuts. We have lots of time, and there's going to be an assignment that you do with somebody else. There's where you put the horsepower, where you guys can both work together to be really creative, you and some other person, maybe a third, to kind of produce something that's really cool. All right, so please don't go crazy with this one. Just hit the requirements because it's going to teach you moving around the camera, again, different forms of lighting, how you balance things in terms of grouping, spinning things around to make them work. It's got to look fairly nice, right? Look like a solar system. There's some challenges that are going to be in your way. In making a material emit light, all kinds of stuff that you need to be able to do. So there's a lot of learnings involved here in this one. Any other questions before we shut this off and talk about other things? Okay, let's close this one off, and then we'll get right into talking about assignment number 1 again, because I want to talk about some things we didn't hit with assignment number 1. And I want to ask your opinions of some of the things, and we'll get right into lighting with Blender for the remainder of the day, and some 3JS. We'll talk about 3JS, which would be the presentation for week 3, even though we're in week 4.